Continuing on with lesson number 3, toss the cup. Yesterday, we started activity 3.2 on page 545. Looking at this spinner. I don't have these, I don't have this page filled in because if you remember, it was a lot of your opinion. You looking at the spinner and making predictions and observations about what's going to happen when you do the experiment. Yesterday, you got a paper clip and with your group spun the paper clip on this spinner 50 times. And then we had to leave and end of the class. So, if you have not already, make sure or go through and count your tally marks for each symbol. If you are the person spinning the spinner, you do not have to go back and copy all the tally marks. Just write down your totals. Once you have your totals filled in, write your probabilities. These probabilities on number 8 are the same. Calculate the experimental probabilities using your data. So those can just be copied from the table onto number 8. Your totals should be whole numbers because that's the frequency. That's how many times the spinner landed on each section. Write your probabilities in fraction form. Each group will probably have a different probability because your spinners probably landed on each section a different amount of times. So the numerators for each probability are probably going to be different from group to group. But what should be the same between everybody in the classroom? The denominator. What is the reason for this? Why should all our denominators be the same?
Because we spin it, we all spin it 50 times.
Perfect. Great. That's exactly right. Every group spun the spinner 50 times. So the denominator is how many trials in this experiment, which was 50 for everybody. Mine landed on a smiley face 13 times, so that's 13 out of 50. Mine landed on the sun 15 times, so that's 15 out of the 50 spins. And mine landed on the star 22 times out of the 50 spins. P stands for probability. What's inside the parentheses is your favorable outcome, what you're finding the probability of. So we're just copying that down from our table. The probabilities that you got after doing the experiment, how does it relate to what you wrote on the previous page? This is what question number 9 is asking. Compare the experimental probability that you just got with the predictions that you made on the previous page. Question number 3 and 4. How close were your predictions? On number 3, I remember we talked about the star having the highest chance and the sun having the lowest chance. Did that actually happen when you spun the spinner? So on number 9, go ahead and write about that. Comparing your results with the predictions you made on the previous page. So here's what I put on mine. I expected the star to occur a little less than half of the time, which it did. Surprisingly, the sun came up more than the face. So let's go ahead and move along to activity 3.3, comparing probabilities using proportional reasoning. If you know the probability of an event, then you can use proportional reasoning to predict the number of times that event will occur throughout an experiment. So if you know the probability, you can use that to make an educated guess with evidence as to what could happen when you do the experiment. As we learned in the previous activity, it might not be perfect. We might not get the exact result when we do the experiment, but it should get us close.
Got it, thank you. I'm glad they came and picked it up.
What is proportional reasoning? If you know the probability of an event, you can use proportional reasoning to predict. Does anybody remember what proportional or proportion means or looks like? Uh-huh.
Like the total amount of, like, not total, but like the size you get, like an example of a hand of celery. That would be.
Oh, a portion, I think is what you're thinking of. A portion, like the size of something. It does sound the same. Proportion in math class was when we had the comparison, when we compared two ratios. Ratios, remember, can be written as fractions. So proportional reasoning was when we set up proportions, which was a fraction equal to a fraction. Like we did in our warm-up to convert fractions into percents. We set up a proportion. Our worked example is going to show us and list out the steps for doing this. So if you ever forget, you can come back to this page, 548, and follow these steps. So let's talk about these steps. The probability that the spinner will land on the sun is 7/20. So 7 out of 20. If the spinner is spun 60 times, you can predict the number of times the spinner will land on the sun section. And here's how you do it. Step 1 is to set up the proportion. Using the probability that they give you. So they told me the probability of the spinner landing on the sun was 7/20. That's going to be the first part of our proportion. And we're being asked how many times, x, we can expect the spinner to land on the sun out of 60 total spins. We're going to spin it 60 times. So that 60 is the denominator. Once we have the proportions set up, we solve it, and we'll have our answer. Well, we'll have our prediction. So as a review, there's multiple ways you can solve proportions. You can look for vertical, up and down relationships between the numerator and the denominator. You can look for horizontal relationships between the denominators and the numerators. Or you can do like this worked example and use cross products. Cross, multiply, and divide. Multiply the numbers that are diagonal. Cross multiply. That's what they did here and here. And then divide. A fraction line is a division sign, so they divided. Cross multiply and divide. Multiply diagonal, divide by that number that was left out. So we can predict that the spinner will land on the sun 21 times if we spin the spinner 60 times, based on the theoretical probability of 7/20. The more we practice with this, the better understanding we'll have. So on the next page, that's what we're going to do. We're going to do a bunch of practice with this. We'll do number 1A together, and then you will do B and C and D in your groups. So we're going to be following these same steps. Set up the proportion using the probability, and then solve it. Next page. Suppose these are the probabilities for the symbols on the spinner. P for probability, so the probability of getting a face is 7/20. The probability of getting a sun is 2/5. And the probability of getting a star is 1/4. If you spin the spinner 40 times, predict the number of times the spinner would land on each section. So we're given the probabilities. That's what we're going to start our proportions with. So for the face, the probability was 7/20, so that's our first fraction. In our second fraction, we don't know yet what our prediction is, but we do know how many times we're going to spin the spinner. 40. We can use cross products. 7 times 40. What do we get when we multiply 7 and 40? We get what? 280. Then what do? We divide by 20. So 280 divided by 20. $20 can't go into 2, but it can go into 28 one time with 8 left over. Bring down the 0. 20 goes into 80 4 times. And that is our prediction, 14. We're talking about the number of times the spinner will land on a section. So it's a whole number, 14 times. So if we spin the spinner 40 times, we can estimate that the spinner will land on the face 14 times. When we do the sun, we're going to be doing these same things, setting up the proportion. The only difference is now we're going to be using this probability, 2/5. The probability of landing on sun was 2/5. Set up the proportion. Again, it's x over 40 because we're making the prediction for the number of times the spinner will land on 40. How many? How did you solve this proportion?
I multiplied 2 times 40, which gives me 80. Because 2 times 0 is 0, and then 2 times 4 is 8. And so then I divided 80 by 5, which gave me 16, because 5 times 16 is 80.
Awesome. So 16 times. Perfect. I'm going to let you go ahead and do the star, because I get the feeling that we get it. So you go ahead and finish off this page, the star, and then on B, what if you spin the spinner 100 times? So doing the same thing, but with 100. And then read and answer C and D. And that'll be all the time we have left of class.